Hey Math 1 students, we are going to dive into your 4.4 Ready, Set, Go notes. So please make sure you've got your packet open. You can follow along with what I'm going through. I know we did some of this stuff in class, so this is probably just a review for some of you, or it's for those of you who were absent. So just follow along, take your notes on the pages that are in your packet, and if you've got any questions, please make sure that you ask them when you come to class next time. All right, so we are going to start with, given this graph, we need to write the solutions in interval notation and in inequality notation. So we're going to start with interval notation. Think back to Module 3. We used interval notation to talk about intervals of increasing and decreasing, to talk about domain and range, things like that. So the things you have to remember about interval notation is we always have our lower bound, and then we have our upper bound. And the lower and upper bound can either be in parentheses or it could be brackets, depending. So remember, anytime it's closed circles, we use the brackets. And then if it's open circles, or if we're talking about positive infinity or negative infinity, that's when we use the parentheses. So these are open circles, and then either plus or minus infinity. So if we take a look at this graph here, there's an open circle at -1, and everything to the right of it is shaded. Well, if we look at those numbers here, they're all getting bigger, right? This number line has an arrow on it. It's going off to positive infinity, which means for our interval notation, we're going to go from -1 to positive infinity. And because the circle is open at -1, I use a parenthesis. And then at infinity, we always use a parenthesis because that's not an actual number. Now for the inequality notation. Remember, your inequalities could be less than, they could be greater than, they could be less than or equal to, or they could be greater than or equal to. So if we look here, we started at -1 and we shaded all of the numbers that are bigger. So that means it's either going to be greater than or equal to. Since the circle is open, it's only going to be greater than. It cannot actually equal -1. So our inequality notation is just x is greater than -1. All right, now we're given some inequalities and we need to graph it on a number line. So this says x is greater than or equal to -3. So we're going to go ahead and put -3 right in the middle of our number line because that's our important number there. We always want to have at least one number to the left and one number to the right. So one number that is smaller than -3 would be -4, right? I go down by 1. Or if I want to go up by 1, that means I'm going to be at -2. Since this says greater than or equal to -3, that means this is going to be a closed circle. So I'm going to go to -3 and draw a closed circle. And I want numbers that are bigger than -3. So if I think about my number line, I know that this is going off towards negative infinity. This is going off towards positive infinity. Well, the numbers that are bigger than -3 are this way. So I'm going to draw my squiggle, and remember to put an arrow because it does go on for forever. All right, for number 3, this says x is less than 2. Since it can't be equal to 2, we know that this one is going to be an open circle. So we're going to put 2 right in the middle. We need one number to the left and one number to the right. So we can see they go right in order, 1, 2, 3. We're going to have an open circle at 2. And since this says x is less than 2, we want numbers that are smaller than 2, so we are going to shade towards negative infinity and put an arrow. All right, here's some more stuff with interval notation. So the stuff I was writing up here might make a little bit more sense now that you see another example of interval notation. So this is telling us we want all the numbers between -1 and 4. Since we have a bracket at -1, that tells us we're going to have a closed circle at -1. And then we have a parenthesis at 4, which means we're going to have an open circle at 4. So now I need to actually make my number line here. So let's see. I'm going to put -1, I don't know, maybe right here. So -1, and then I'm going to go 0, 1, 2, 3, 4. Okay, so good, that worked. I'm going to go one more to 5, and I'm going to go one more to the left to get -2. So both of my important numbers here have at least one number on either side. All right, that's what we're always going to be looking for in your graphs. Well, now I know I need a closed circle at -1. I need an open circle at 4. And I want all of the numbers that are in between that, which means I'm just going to shade everything in between. I'm just going to connect my two circles that I made. There we go. For number 5, graph the set of numbers represented by this interval. So we're from -infinity to +3. So 3 is going to be an important number here. -infinity isn't actually a number, but if we think about it, it's all the way on the left of our number line. So I'm going to write that there just to remind myself that this is where -infinity is at. But I'm going to go ahead and put 3 in the middle. I'll put 2 to the left of it and 4 to the right of it. Now, since that's a bracket, I know that that's going to be a closed circle. So I'm going to go ahead and close it. And I'm just going to shade towards -infinity and draw an arrow. So really I'm looking at numbers that are less than or equal to 3. That's what this interval represents. All right, so now let's look at some words. So I'm thinking of a number that is at most 12. So the key words there that we're going to think about is it's got to be at most 12. So if we kind of reason through that, if I want something that is at most 12, it means it could be 12 or it could be smaller than 12. So 12 or smaller. So if we think about our different inequality symbols, the symbol that goes along with that is less than or equal to. So we want numbers that are less than or equal to 12, because that's going to give me numbers that are smaller than 12, or I could have 12 itself. So if we think about the numbers that satisfy that, 10, 11, and 12 are all less than or equal to 12. For the next one, I'm thinking of a number that is greater than 4. So this one actually gives it to us right away. Greater than means we're just going to use the greater than symbol. So x is greater than 4. If we think about the numbers that satisfy that, well, 0 is not 1, 2, 3. 4 is not either. 4 is equal to 4, but it is not greater than 4. So the only number that's going to satisfy that one is going to be 5. And then I'm thinking of a number that is no fewer than 2. So again, we kind of have to think about what no fewer than means. So no fewer means that it cannot be smaller than 2. So not smaller than 2. Well, that means it could equal 2 and it could be bigger than 2. So the inequality that's going to go along with that is going to be x is greater than or equal to 2. Again, the no fewer means it can't be smaller, but it could be equal to it and it could be bigger than it. So that's the greater than or equal to symbol. So the numbers that satisfy could be 2, 3, 4, and 5. All right, moving on. So now we're going to go the other way. Now I'm going to give you an inequality, and you need to write the sentence that goes along with it. So this symbol here is the less than symbol. So this says x is less than 0. So if we think about numbers that are less than 0, they have to be negative. So -3, -2, and -1 would work for that. This is the greater than or equal to symbol. So this says x is greater than or equal to 36. So if we look at those numbers there, none of those numbers are greater than or equal to 36. So we're actually not going to circle any of them. I sometimes like to write myself a reminder then that, hey, none of these ones work. This next one, we've got two different options. So some students like to read it exactly as is, which I think is perfect. So if we read it exactly as is, it starts with -3. So it says -3 is, that's a less than or equal to. So less than or equal to x. Right? Exactly as it is. -3 is less than or equal to x. Now, some students might look in this and go, oh, I don't like that because it's written backwards. And so what we can do is we can actually write it in what we call conventional form. We can put the x on the left. If I switch the x and the -3, I have to also flip my inequality symbol. So it's actually going to make it look like this, which if we read that says that x is greater than or equal to -3. It does not matter which way you write it, but either way we have to be able to circle numbers that satisfy the statement. And for me personally, it's always easier to have the x come first. So if I want to be greater than or equal to -3, it means -3 works, and it also means that I can be bigger than that. So all of these numbers to the right would work. Now if we left it as -3 is less than or equal to x, we can reason through the numbers that go here as well. If -3 is less than or equal to x, it means that -3 must be the smallest number that works. And so if we look, -3 is the smallest number that works. We picked all bigger numbers. All right, on to the go. So read the following situations, determine if the answers are appropriate, and justify your answer. So we did do these together in class, but I'm going to do them in the video as well because they're hard to understand, and so maybe hearing them a second time might be a good idea. So a student was asked to graph x is greater than or equal to -4, and this was what was drawn. Would this graph be appropriate? Justify your answer. So what I want you guys to do is I want you to think about if I asked you to graph this inequality, what would it look like? And I always like to then write myself some notes. So I know that this is a greater than or equal to symbol. So greater than or equal to, which means if I were to make a graph with a greater than or equal to symbol, then I know I would need a closed dot. And if I were writing it in interval notation, wherever that closed dot is would have brackets. So these are just things that I kind of think of when I see a greater than or equal to symbol. Also, since the x is on the left and I want numbers that are greater than or equal to -4, I know that I'm going to need to shade to the right, because those are numbers that are bigger than -4. It also means that I'm going to go towards infinity. And I'm going to go towards positive infinity because those are the bigger numbers. So if I want to look at this graph and decide if this is correct or not, this has a closed circle, it's shaded to the right, but it's at the wrong number, right? If we look, they've got a closed circle at -7. We're supposed to have the closed circle at -4. So that's a problem, all right? Which means that's actually the first thing that you have to say in your answer. You have to say, no, this is wrong. This graph is wrong. And then there are going to be 3 things that I'm going to check to see if you talk about in your explanation. So we set up here that if we were to graph this ourselves, we would need a closed circle. So I'm going to actually go ahead and write my first thing is a closed circle. So they had that right, so I'm just going to put a check mark, like, yep, they had a closed circle. We also said that they need to shade to the right. And if we look at the graph that's given, it was actually shaded to the right. It's going off towards positive infinity. So that's a good thing. The last thing that we need to remember is that this closed dot needs to actually be at -4. So the circle should be at -4. This is actually what's wrong with the graph. So I'm going to put an X here. These 2 things about the graph were correct, but this third one is the thing that was wrong. The circle should be at -4. So this is what needs to be fixed, or this is what was wrong. They put the dot, or the circle, at -7 instead. And that's what the problem was. So those are going to be the three things that I'm always looking for in your justifications. Did you talk to me about the open or closed circle? Is it shaded the correct way? And where is the placement of that circle? Now each justification is going to be a little different because it's not always going to be, I'm going to give you an inequality and then I'm going to have you analyze the graph. Sometimes it goes the other way, but it's still going to be those three things that I'm really looking at. Okay? One more example down here. So now we're given this graph and we need to decide if student 1 or if student 2 is correct. So we were given a graph. Student 1 decided to make an inequality and student 2 decided to make an interval notation. So we have to decide which student is correct. In order to do that, I would look at the graph myself and try to decide what is it that I know about this graph. Well, I know that since there's a closed circle, it means that if I'm going to do an inequality, then it must be equal to 2. It also means that I would need a bracket at 2. I would need a bracket, or I know that it would have to be equal to because it's a closed circle. When I look here, it's shaded to the right, which means my numbers are going off to positive infinity. They're getting bigger than positive 2. And if I look at these two student examples here, student 1 is saying we want numbers that are less than 2. Student 2 is saying we want numbers that are between 2 and infinity. Student 2 is actually the correct answer then. So we need to say that student 2 is correct. And again, there's going to be three things that we're really looking at here. The placement of the number, whether it's an open or a closed dot, and the direction of the shading. So we're going to talk about those three things. So, since there was a closed circle at 2, so a closed circle at 2, that meant that we need to have a bracket at 2, which student 2 did correctly. Then we also know that it was shaded to the right. On the graph, that's what we were given. It was shaded to the right. So what that means is we want the numbers to go towards infinity. So the numbers go to infinity, which really means infinity is in the interval or is part of your interval. So we took care of all three things again. Closed circle gave us the bracket. It was at 2, so we acknowledged that. And then we talked about the shading to the right, which tells us that the numbers are going to infinity. Now if you look, these justifications look a little different. All right, but they're still getting at those same three things. It's just that on this one, I kind of put the two of them together. Your justifications do not have to look exactly like mine, but they do need to include those three big ideas. The placement of your circle, whether it's open or closed, and the direction of the shading. And again, some of them are going to look a little different because you might not actually have a graph. So you might be talking about the intervals and the brackets versus parentheses. Okay, but those are all the things that you need to include. I know it gets confusing, so please, please, please make sure you're asking when you've got questions. All right, come on in and see me for office hours or ask in class or stop by the MRC. All right, you guys have a quiz coming up on the block day this week, so please make sure you are prepared for that. Thanks for watching.